The following series of slides will discuss the green seeker and the weed seeker and the NDVI technology on which they are both based. The green seeker is used to apply variable rate fertilizer to plants based on their needs as assessed by the green seeker itself. You may recall seeing the weed seeker in the field-based tutorial videos on the Graham Centre resource website. The weed seeker applies variable rate herbicide as assessed by the presence or absence of a detected weed. Here you can see that the spray nozzles on the spray boom are activated only where a weed has been detected. Both the green seeker and weed seeker apply variable rate technologies according to how much fertilizer is needed in the case of the green seeker and where the herbicide is required in the case of the weed seeker, where the rate of the herbicide is constant. The variable rate technologies developed here are both based on remote sensed information derived from the plants themselves. All objects reflect light differently and in different wavelengths. This information allows us to distinguish between plants, soil, water, and other objects in the landscape. The following slides will discuss how this process occurs. The light and energy that is reflected by different objects is based on electromagnetic radiation. This is different from electromagnetic induction used in the EM surveys. Electromagnetic radiation comes primarily from the sun. As it travels through the atmosphere, it can be transmitted, that is, it travels from the sun through the atmosphere and reaches the Earth's surface, and some of the radiation will be scattered as it travels through the atmosphere. For example, the scattering could occur due to the water vapour from the clouds, and this scattered radiation may or may not reach the Earth. Electromagnetic radiation that reaches the Earth can then be absorbed, where the radiation goes into the Earth, or again it could be scattered. It is this scattering of electromagnetic radiation from the Earth's surface that provides a reflected signature for different types of objects. It is this signature that provides us with the basis for remote sensing from on-ground instruments such as the green seeker and weed seeker, or off-ground remote sensing instruments such as those flown in planes or attached to satellites. For the electromagnetic radiation to be transmitted from the sun through the atmosphere and reach the Earth, it must travel through what is known as atmospheric windows. These windows are based on the wavelength of the radiation. The radiation wavelength can vary from long wavelengths over 1 meter long, as shown by the microwaves at the left of this diagram, to wavelengths that are very short, such as ultraviolet or UV radiation that are fractions of a micrometer. The vertical axis on the right of this diagram shows the percentage of radiation from each wavelength that is transmitted through the atmosphere to the Earth. 0% is at the top, near the Sun, and 100% transmission is at the bottom, near the Earth, in this diagram. 100% transmission indicates that the radiation has reached the Earth's surface. The point to note on this diagram is that from the electromagnetic radiation spectrum, that is the whole range of wavelengths from the EM spectrum, almost 100% of the visible and near-infrared light emitted from the sun can travel through the atmospheric windows to reach the Earth. This diagram shows that from the full range of the electromagnetic spectrum, it is only the near-infrared and the visible light that travels through the atmospheric windows from the Sun and can be used in remote sensing to identify specific objects on Earth. In remote sensing, a specialized camera is used to detect the amount of reflectance of electromagnetic radiation from the Earth's surface. This radiation is detected in regions classified as visible blue, visible green, visible red, and near infrared. Different objects such as water, soil, plants, healthy vegetation, and different types of vegetation will show a different amount of reflectance from each of these EM regions, hence each of these objects exhibiting a different reflectance signature. This reflectance signature is also known as the spectral signature of the object. To summarize to this point, EM radiation comes from the Sun. It is scattered, transmitted, or reflected as it travels through the Earth's atmosphere and reaches the Earth. Short wavelengths scatter more. Some wavelengths are totally absorbed by their atmosphere and don't reach the Earth's surface at all. Wavelengths that are transmitted well and are transmitted through atmospheric windows are what we use for remote sensing. This slide is an example of how much reflectance could be expected in each EM region from different objects such as soil, vegetation, and water. For the purposes of agricultural production where plant health, vigour, and density are important, the amount of reflectance from the green, red, and near-infrared wavelengths are very useful. The red band is specifically used to differentiate green, healthy vegetation. The near-infrared band is useful for estimating biomass and emphasising contrasts between soil and crop and land and water. Thus, the NDVI, the Normalized Difference Vegetation Index, is a measure of the reflectance calculated from the near-infrared NIR and the red bands according to the equation shown in this slide. NDVI can be thought of as a measure of how green is it, how green is the plant. A high NDVI value indicates a greener, healthier plant. A low NDVI value is indicative of a plant that is less green, and that could be due to water stress, or a younger plant that is still becoming established, or an older senescing plant. Now that we know all about NDVI, how does it work in the weed seeker and the green seeker? To look at the weed seeker as an example, as the instrument is moved along over the ground approximately 60 centimetres above the ground surface, a beam of red and near-infrared light is emitted from LEDs onto the ground. You can see this in the weed seeker tutorial video. A sensor in the weed seeker then measures the amount of reflectance from both the plant and the ground. Because the ground and plant will have different reflectance values, the computer can determine if the reflected light is from a plant. If this is the case, a quick-fire solenoid valve is activated to spray the plant with herbicide. In the green seeker, the computer would be determining how green the plant is and whether or not fertilizer is required. This plot shows us how the value of NDVI can change over a growing season, from next to zero, which is close to bare earth, when the plants are very small, less dense and just becoming established, to a higher NDVI reading when the plants are growing well, fully established, very green, and then as the plant begins to brown off and begins to senesce, the NDVI reading falls again until the plants have completely died, completely disappeared, and then we're back to bare earth readings again. Obviously, this is the NDVI reading for an annual crop.